Good evening, everyone. Welcome to Day 3 of the ATAL Faculty Development Program on AI in Action, Bridging Theory and Practice in Data Science and Deep Learning, organized by Department of Computer Science and Applications, St. Mary's College Autonomous, Thrissur. Before we begin, a gentle reminder. Please keep your microphones muted and cameras turned off during the sessions. Kindly use the chat box for queries. As per ATAL FDP rules, attendance and feedback submission are mandatory for certification. Participants are required to submit the feedback form. The link will be shared at the end of the sessions. We request your cooperation for the smooth conduct of the sessions. Our first session today is on the topic, a foundational approach to machine learning algorithms, led by Mr. Mohammed Afsal. To formally introduce the speaker, I invite Mrs. Prasida A., Assistant Professor, Department of Computer Science and Applications, St. Mary's College Autonomous, Thrissur. Ma'am, please take over.
Thank you, Ms. Geetu. Good evening, everyone. It is my pleasure to introduce today's resource person for the session, a foundational approach to machine learning algorithms, Mr. Mohammed Afsal. Mr. Afsal is an accomplished technopreneur and currently serves as the Chief Technology Officer at Robomy, St. Berhad, Kuala Lumpur, Malaysia, a company he founded in 2018. He has more than 22 years of experience in embedded systems, artificial intelligence, machine learning, and software engineering. He has also been the founder and CEO of Alif Tech Product Solutions from 2004 to 2018, leading innovation in diverse technology domains. His expertise spans embedded systems, deep learning, edge AI, FPGA, ASIC design, and generative AI development. Mr. Afsal is actively involved in academia as well, serving on the industry advisory panels of several leading universities in Malaysia, including Taylor University, Asia Pacific University, Sunway University, and AIMST University. His achievements include developing over 100 plus products, securing patents for advanced technologies, winning an international gold medal for innovation, and being recognized as Malaysian Human Resources Development Corporation accredited trainer. We are truly privileged to have him with us today to share his knowledge and insight on machine learning algorithms. Let us warmly welcome Mr. Mohammed Afsal. Sir, please.
Okay, thank you very much, dear friends. I hope all of you can hear me. Is it clear? Any of the organizers can let me know. So our session, I know, is a part of a longer session in AI and machine learning. Currently, I am in Malaysia. I work from both locations because we have two companies. Robomy is in Malaysia as well as in. So currently it's 8:36 now. It's 2:30 ahead. It's after a long work day, and also I have little sinusitis. So I hope if you feel any issue with my voice, if it's not clear, please let me know by opening your mic. So basically, this session I'm going to share my experience. Looking into slides, don't think that's going basics of AI and ML. I have a lot of experiences to share from early AI to modern AI, because I have been working on a lot of AI or so-called AI for about 20 years, because many of them that we used to call AI previously is not even called AI now. So the idea is there are not a lot of differences between how AI we see in theory and how AI is practiced, especially in production. Today itself, we had a very serious issue. Just now, I'm after that issue with one of our clients, where we had a road monitoring system, camera-based road monitoring system. We use one of the latest edge hardware that it was using live road monitoring potholes and all those things. So some of those things failed. Later I will explain to that. So this actually, I mean, it's not my first experience. There are a lot of experience that some of when we practice AI, especially when we provide AI to our clients, we have to be very careful. It's not the same like what we see in theory or what we see in open source models. So before beginning my session is I mean bound around 3 points. One thing, I know most of you are teaching faculties and researchers. Actually, I also work as a teaching faculty. Currently also I work as a faculty for many Malaysian universities. I work as a researcher as well. Together with that, I am an industrialist. I have been running my startup from beginning of my career. So my first advice to all of you is that AI is unlike any other technology. So we need to have these three vision. We need to have a vision of an academician. We need to have a vision of a researcher, as well as we need to have a vision of industrialist to achieve something what we call something realistic in AI. So the thing is, AI can do a lot of things now, or we assume AI can do a lot of things, or we see this model that 90% accurate. We see that that model can give like for example this specificity, match sensitivity, and all those stuffs we see in research papers. That's the academic part. We start from there because it's a struggling time for industry, because unlike like 3 or 4 years back, things are changing very fast. That means some models that we are working into can change any time. So that also applies to you researchers as well. So I have seen people working on researchers that is already obsolete because industry doesn't want that research now. So that's a very critical thing for AI researchers, academicians. So I work as syllabus review. I work in syllabus review committee for many universities. So we see that every year they review the syllabus. By the time they review the syllabus, a lot of things has already changed. So that also applies to the employability of the people as well. So generally, in my session, I want to to become more interactive, because when I share my experience, I would like you to share your experience as well. You can, I can, as I mentioned, I have a very long experience in this industry, AI, IoT, and things, working with many clients. I have worked with many experts as well, so I can share the story. So the idea is, one of those projects that I am currently working with is replacing an entire software company with AI. You see, all of this, one side, I also believe that this is, how we call it, this is an imaginary project. That's why I am working in this project, because I am, as a developer and as an architect, I am against the idea of vibe coding. You know vibe coding, right? Coding by telling a story. Actually, I used to tell this in my classes, as from 2018 at least. Software engineers should worry a lot, because there will be systems that you tell a story, it will give the program. But now a lot of people are behind vibe coding. People are replacing AI expertise with software tools. A lot of industries are using it. They are forced to use it as well. For example, we had a client from overseas. They had a problem. They are mobile tower what we call, they install mobile towers, they install and maintain mobile towers. So they want to optimize their diesel generator performance using historic data. So that's a machine learning problem. You can use if they have last 5 to 10 or even lesser data of the usage together with other data. The other data is a question mark, is a point. I mean, is a uh, is an is a question in front of the data scientist to understand what kind of data is needed for this project. But the point I'm looking into is not that. So as usual, I quoted an 8-month duration. That's what supposed to do what we were doing, but the client wants it in 3 months. So it's a very less than uh, half time for the project. So that means they are also expecting, rightly or wrongly, they are also expecting us to use these kind of tools to develop codes and deliver to them. So whether it works or is a different point of discussion. A lot of people ask me during my sessions whether AI is intelligent or not. Previously, if we ask, is we I mean it was a question from laymen. I mean, when I mention laymen, they are not related to ICT or related technologies. It's not. I mean, anyone other than IT or AI. So, but now, even after the success of transformer neural networks, people, even researchers, are also asking whether AI is intelligent when we generate something using generative AI, whether they are generating just like humans, or it's just like an autoregressive model. You know, an autoregressive model will take inputs and later it will add outputs to inputs, and regressively they do an autoregressive operation, and they output. So transformers, actually, when the decoders in the transformer models are actually working autoregressive. So these questions are asked by developers as well. So there is a lot of what you call, recently, Sam Altman mentioned AI bubble, right? So this applies to all in academics, researchers, and industries. So I have seen a lot of researchers going behind Gen AI without any valid, I mean, how we call, without any valid uh, reason. So they could have accomplished that with other models. That's where we have a lot of other models as well. So that will save a lot of energy. I mean, that's consuming less power. That is lightweight and all those stuffs. So there is a lot of buzz around Gen AI. So that's how the projects comes in. But as a company, whenever a client requests us to engage in some sort of activities, we have to do that. So that's why I have projects like this, pricing the entire system and their software company with AI. So I know we don't have questions like whether AI will replace humans, etc. in this session. So that's, we see this one of the solutions that we work uh, on AWS. So you see the complexity of the solution. There are a lot of components. So do you think all of these components, which requires its own programming, its own careful layout, can be done by AI, by Gen AI, which is autoregressive and also which is not what we call, which can hallucinate in general terms, etc. So AI, generally, modern software development itself is a complicated stuff. When I mean, most of you will be in your 40s, some of you will be in 30s, and I think some of you will be older than that as well. So if you worked in software industry just 20 years back or 15 years back, you will be mostly working on monolithic software. Monolithic software by mean you develop a software, you want to compile one version for Linux, one for Mac OS, one for Windows. So then you distribute it in a CD, or in those days even we have done in floppies as well. So sorry. So monolithic to current software architecture is microservices based. That means every application that you see, even the Google Meet uh, that we are using, are components of hundreds and sometimes even thousands of micro components that will be working in many hundreds of servers. So each having different, each having different functions, and they will be in different locations. For example, I joined from Malaysia, you joined from India. So whenever you send that invitation, I see the time in Malaysian time. You see the time in Indian time. So a microservice is running to monitor my information. So whenever you share the email, I will see in my time. So that's a microservice that is monitoring, or more than one microservice that is monitoring the location. It can be from IP or any other ways. So there are hundreds of such systems working synchronously. So this was the project. I mean, I can show the actual project. So that's why I'm showing a different one from the internet. So the kind of project that replacing the entire software company with AI. So just coming back to my machine learning solutions on AWS. This AWS, we have one way of doing. I mean, when we do in cloud, you have, uh, you have different cloud vendors that like AWS, Azure, etc. So even the software architecture is complex. By including AI and ML as a part of that software architecture, we have a very complicated system. So we know that we have the feeling of that, or if you are a developer developing production level software for their clients, you know that sometimes it's easy for you because some of those things, for example, I mentioned about the location monitoring, that may be pre-built for you. You can just use that service from Google, but that will be running from Google. You have to connect it rightly with your service. So some of those may be needed for your AI and ML application. So uh, it may be connecting at different stages of an AWS workflow. So come So developing something like this where you can replace the entire software development company, in my opinion, is hazardous. So what is your opinion? Even though I am a part of this kind of project, even I am also working on a similar system with replacing an entire department with AI. So it's a trial project with one university here. So I'm also a part of that. That's a research project actually funded uh, under the, I mean, under the government grants. So what do you think? Those who think that this is not possible or this is hazardous can raise your hand. The idea is that having a production grade system needs knowledge, detailed knowledge of the model. That's somehow academic because sometimes you may need to modify the models, or sometimes more than that, you may need to know, uh, I mean, the ways of using the model. For example, recently have we have uh, used an AI accelerator, accelerator from Hilo. So normally we are running YOLO models. So maybe I just want you to be a little bit interactive because I don't know whether you have worked in AI projects or you are doing AI research or anything. I'm not sure. So can I ask, maybe please 5 minutes I will take to know a little bit about you so that I can well interact with you. I just 5 minutes. I just switch off my presentation. Can you please interact with me? Let me know. So anyone who has previously worked on industry level AI projects, any projects, maybe you as a faculty, you may have relation with industry, some faculties who work with industries, etc. Anyone who work can raise his hand just to see. Okay, so anyone who are doing AI, I mean research in AI, who are doing, I mean they are doing AI researchers currently. They have very strong foundation in AI, and they are doing researchers in AI. We have two kinds of AI after the Gen AI revolution. One is a discriminative AI. So with the Gen AI, what happened is that a lot of people for they have forgotten the discriminative AI. So that's why earlier I mentioned there is a trend among even in industries and researchers to straight away take a model, an AI algorithm. I mean, that's Gen AI. Let's say, for example, a large language model that's very heavy to run in order to solve a problem. So there are a lot of models, I mean, in the discriminative way that we can use. For example, even without using neural networks. For example, if you see uh, tree-based models like gradient descent, random forest, all those models can perform as well as a neural network or deep learning if the data is tabular data. So we see trends that straight away people start using neural networks for projects. By doing so, you can see a lot of, I mean, you are using a lot of resources, you are using a lot of I mean development time, etc. Generally, the workflow is we have data, we select that algorithm, we develop the model, and then we do the prediction. So selecting the algorithm from an industry perspective is very crucial. So previously, like for example, in last uh, at least 5 to 6 years back, what we did is we have to manually uh, test every algorithm. For example, if you have a problem, we will test linear regression, then we will evaluate it, we will do cross validation, then we will test another models. We will we may take, like for example, we may take a tree-based model, we will evaluate it. So currently we have options called auto ML, auto machine learning. It can be a part of ML ops. I think you have heard of ML ops. Now every ML project is put under, maybe you can note my point, every ML, I mean every machine learning projects, in order to automate the workflow, we do as an ML ops, machine learning operation, just like DevOps. You see in development and operations, we have ML ops. So in the ML ops cycle, we have the auto ML. Auto ML algorithms will work on the data. They look into data. Of course, the data pre-processing, data cleaning, and all those things should be manual in some way, because that is something that need human expertise. In my experience, I have, for example, in AI MST Ames University, it's actually a medical university. So I was taking an AI workshop, a workshop for medical doctors. Actually, they are professors. So I showed one of the data that I have. So I mentioned that, for example, the data you may be very familiar, the PIMA Indian diabetes data set. So it's a basic machine learning workshop. It's for medical doctors, not for developers. So I mentioned during the data pre-processing stage that if you see, uh, you need to clean this data. You see there are a lot of issues. Skin thickness is 0. That is a mistake. So insulin also is 0. That is also a mistake, but that was my mistake. So one very old doctor out there, he mentioned if his pancreas is removed, then his insulin will be 0. So something the data pre-processing stage before we select the algorithm is one of those stages that is not yet automated in AI or in machine learning workflow that needs human expertise. For example, some data you may see as an outlier. Outliers are some values that are outside normal ranges. So an outlier for one problem may not be an outlier for another problem that the subject matter expert should come and say. So that is the stage where currently I am working on few medical projects as well as a recent project and LLM for medical application. So in order for me to tell the data is correct or wrong or how to clean it, what we should remove, etc. I have to talk to a medical expert. So that's the only stage. I mean, that's the stage where that's not yet automated. The other stage, as I mentioned, the selection of algorithm. There are hundreds of algorithm. How are you going to select the right algorithm? It's actually from academics, it may not be an issue because when you write a research paper, you only need to show your paper. I know since I work on many papers as well, I help a lot of researchers on writing their theses and papers. So your aim is only to show that you have an improvement with the other system, and you have a lot of brackets where you have a limited conditions. But in production, that's not the case. When we are delivering a machine learning solution to our client, let's say if you're delivering a solution, medical solution, uh, so if it makes a mistake, uh, life may be lost. So for us, it's not an improvement from the previous system. It's how we can solve the client's problem in the best way. So selection of algorithm is a very crucial step. Some of even we develop some of our own solution to evaluate various model for some problems, because when the data changes, the record algorithm may also change. So in reality, the most challenging stage is selection of algorithm and getting the right result and generalizing the result. Generalizing the result is very important. In many of my sessions, many people, especially from academies, they may wonder when I say whenever we get 100% accuracy, uh, we think the model is bad. We don't what you call we don't relay the model. That's we suspect that overfitting has happened. So getting maximum accuracy is not our aim as well. So there are different problems will have their own different criteria on accuracy, sensitivity, specificity, and all those parameters. So selection of algorithms, as I mentioned, is very important. So even after developing the model, we test it. Maybe in your previous session, you might have learned that whenever you have the data, you won't use all those data for training. You will keep some of those data for testing. So we assume that there are some generalization may happen, but we cannot we can't make sure that we have gotten all or we have considered all different scenarios in the data. So that's where our assumption of the generalization fails, especially in industrial projects. So what happened is that whenever we test the project, it will work. But when we deliver to our client and they start using it on their real applications, the project will fail. So I have much experience on that as well. But if you have time and based on your questions, I can delve more into my experience. So even if we have a very clean data, we have the best algorithm, and we have developed the model, and it has given the required accuracy, there is no time for us to rest actually. So that's where in our machine learning ML ops workflow, we may sometimes automate data collection, we may monitor the accuracy, other parameters. Now we have ways to look into explainability as well. AI, normally we say AI models are not explainable, but some of the recent models, we have techniques to explain why this is happening. So for example, if it should be predicted as uh, diabetes, but it's not predicted as diabetes. Uh, by some other ways, he was detected as diabetic. So previously, the only possibility was to add that into the training data, and we do the training again. So you might have gone through data augmentation as well in your previous session. I hope so, where we create more data based on the available data. Okay, coming back to the explainability. So now what we do is in our ML ops is sometimes we automate the process and we collect the data, and sometimes like in image processing kind of applications, we may have a greater job in data pre-processing. For example, in object detection, you might have seen in your previous classes, we have to annotate. So in any of my discussion, if you have not, I assume that this is the third day, so you have gone through a lot of basics, as I was told. So if you are not familiar with these terms, maybe you can let me know. So you have to annotate, right? So when you train a model for computer vision, you have to annotate that model. I mean, you have to annotate that object. You have to give the description. But if it's a more complicated model like a segmentation model or captioning model, etc., you may have more complicated data pre-processing. So in order to do that, sometimes we have to write our own. So recently we developed our own solution because the solution available in market is very costly. Our own solution to automate that workflow for image processing tasks, so that this annotation can be somehow, some of the annotations can be automatically done and put into the training workflow, so that the model can be improved based on the results that we are getting. So what I was really telling is, from a production point of view, when we deliver a machine learning solution to a client, we are having a long-term commitment. And this applies to all software actually. But in machine learning, even if we are not doing that, the model will actually, the performance will decay. So you have to, how we call it, you have to maintain the model. So in the production level, maintenance of the model is sometimes more complicated than developing a model. You can just see what the story is happening from the GPT-4. They have released a model. It was a very big surprise to the industries. Actually, we have been using from GPT models from GPT, early GPTs. So after that, we see they are struggling to maintain the model. The model starts hallucinating. They have jailbreaking. I think you are familiar with the term jailbreaking, where you have, by some kind of prompting or some kind of coding, etc., uh, you can you can overcome the guardrails of a large language model. Jailbreaking was very easy in the early GPT and Gemini models. Just like you blackmail a human. If you blackmail the LLM, they will just open up whatever, they will tell whatever you ask, even if it's illegal or anything. So they are now struggling to maintain the model by training it with more data, finding the issues, and solving it with other methodologies, etc. So in a production environment, maintaining a model is more difficult than some or in most scenarios than developing a model. So I hope if you can ask questions in between as well. So generally, uh, in a discriminative uh, machine learning, we have batch or streaming data. I put batch or streaming data. I may need to introduce some other platforms. For example, you may be, let's say if you have the data, real-time data coming in, and you want to update the model every time the data is updated. For example, you have an e-commerce platform, people are purchasing, and you have a recommendation engine running there, so that when you buy this, they will recommend that. So that also keeps on changing. So you have to recommend the best suited product. That also keeps on changing because millions of people are purchasing. So developing a model and keeping it for some time may not work here. So you have to work with streaming data coming. So that's how sometimes we hear of technologies like incremental training. Just like humans actually, every time we see something, we don't learn from scratch. Actually, we increment our knowledge. So incremental learning is one of the topics that that uh, the industry or the uh, AI research community is proposing. So anyway, uh, you might have heard of like modules like Python modules like sklearn in your previous session. I'm not sure whether you had hands-on sessions or not, but Python modules like sklearn cannot handle streaming data. That means also another thing is we have the issue of big data. So let's say Amazon. Amazon is working with millions of, let's just consider their e-commerce platform. They are working with millions of customers, millions of people are purchasing. So they have to update their recommendation system, which is a machine learning model based on the new purchases happening. So it's a streaming data and also it's a big data. So you can't even do that in one server. So that's where we have platforms like Apache, Spark ML all coming in, which is used by industries and open source, where we can have real-time model development. I'm not going into the details. Uh, I'm just mentioning how industry is handling, because many times I am lecturing in universities. I'm also working with researchers. What I see there is that uh, since they are not familiar with the industries, they always tend to use tools that are not, highly useful for that scenario. For example, just like I mentioned, sklearn is good, but if you want to recommendation engine to work in real time, you have to use real time model development kind of thing. So this is also an application where you have like we have worked with one industry. It's not a sensor, actually it's a uh, hard disk manufacturing company here. So they want to optimize their water usage. Malaysia is famous for their semiconductor industries. They are revamping their semiconductor industries. So one of the issue, it's not the issue, one of the requirement in semiconductor industry is water. You need a lot of water uh, for at different stages. So they want to optimize the water usage. So I went there to train their employees. Actually, that since their data is very confidential, they don't allow anyone to work on their data. So they want us to train their employees to work so that they will work on their data. So here you can see that in these kind of scenarios where you may not need a real-time modeling, because even if you process in batch is okay. Like you have your historic data, you collect the recent data, you put it in the ML ops workflow, and you train the model by with the new data coming in. Because sometimes streaming machine learning will require more computational capabilities, etc. So that's where in AI, in machine learning, you have to use a model that is best suited, optimized for power and other requirements set by the clients, not not even something that's giving the highest accuracy. The highest accuracy model may be consuming a lot of power. So the client may say, "Oh, we don't want that accuracy because it's not a very crucial thing for us. So even if we can save 10% of water, it's a very big thing. But if if you are using more electricity than what we are saving, that's a wastage for us." So a best performing model is not the best option here. Is the optimum model that can satisfy the client requirement, looking into all the parameters. I repeat here. If you haven't noticed this here, if you can see, they have to save the water, because saving water is good for nature. At the same time, they have to save money. But if they are spending more money for saving that water, then it's not a lucrative project. So, as an industrial model developer, we have to look into that. Even if you develop the best model, the highest accuracy, the client may not accept it. Another thing is in the choice of data. So nowadays we have multimodal models, right? You may be familiar with that, models that can handle multiple types of data. So previously what we did was, if you have multiple types of data, we will come out with a particular data that is a fused or combination of that data, or we do data engineering techniques to create some data from that different data sources. But nowadays we have option to combine, especially with the Gen AI models, tools like variational autoencoders and all those. With all those things, we are able to combine different data models. It's not models, so we call it multimodal models. The data that can handle multiple data as input or output. So here we have a different. We have a different challenge. Previously, we have, let's say, if the data is numeric, it will be numeric. We have to clean it, we have to pre-process it, we have to develop the model, so and so. If it was image, we have to annotate, we have to clean it, we have to remove noise, we have to annotate it, develop the model, so and so. But now we have an opportunity to use multiple types of data in our projects. So the selection of those data, again, according to the optimal way. So as industries, we have our challenges. For example, this model will give 95% accuracy, but it will take 1 lakh rupees just to train. And that's not worthy for developing that. But that other model is just 85% accurate, but it's just taking 5,000 rupees to train the model. So what we do is we liaise with our client, telling that depending upon the project. So we are selecting this kind of models, because this kind of data sources, because it will save you. It may be less in accuracy, but it can save your money, because the other model development will take a longer time and also a lot of money. So selecting the right data types and bringing it together is also a challenging task for industrial model development. Later, if I have time, I can go through my experiences as well. Again, some of my experiences are confidential. So I will be giving some just an overview of that as well. We have a recent development in ECG modeling, ECG electrocardiogram. So talking to one of the prominent cardiologists in Malaysia, he asked to add another two input sources. He said ECG only is not reliable for this project. So he asked to add another two input data. So one of those data is an image. So complexity of project change a lot. He's a part of our project. He's a very prominent expert. So he say combining all these three data, then you will have a better model development, because this is a medical solution, right? So that's again going back to the challenges in developing the model. Even starts before developing the model, selecting the right data or the right combination of data. If you are going with Gen AI or multimodal models, is very important. So the historic, I mean, the traditional way is just like we have the historic medical data. You select the right algorithm, you develop a model. So this is what we do in academies mostly. Or we add an additional step of data pre-processing, or clinic data, or data augmentation, data engineering, and all those stuffs. So what I was mentioning now is developing a project with an industry point of view. Especially, we have a lot of foundational models now. So what is a foundation model? I think you have dealt in your previous session. Those models can act as a model for further model developments. So foundational model, actually the term become popular with large language models, where you have the open source models, they call it foundational models, which you can fine tune, or which you can what they call we can use as an RNG. RNG, you may be familiar. I'm not sure. Retrieval augmented generation. So when you have the foundational models, so you can, if you have a very good foundational model, actually that's how we work on. Small companies like Robomy never develop a model from scratch. Is too tedious for us. It will take a long time for collecting all those data, etc. We also work on open source models. That's how we can provide a solution. We provide a solution that's low cost to our clients. But the idea is modifying the foundational models. Sometimes we call it base models. Is challenging. You need that capability to fine tune it using the proper technologies or proper methodologies. That's how every day you see, especially in LLM, every day you see papers coming out, or better way of fine tuning, better way of training LLMs, and even better way of implementing reasoning kind of high roles with models like hierarchical reasoning models, HRM. HRM is a very new concept. Maybe it can overcome transformers, I'm not sure, but at least for some specific reasoning problems, it has already outperformed transformers. So that's a very, if you are doing, if you're planning for a new research topic, that's one of the topics that I can suggest. Many people are just going behind transformers. Yes, we have space for research, but that's very limited. Transformers already reach, I mean, at least the vanilla transformer already reached its limit. And so you see, even when OpenAI said they are releasing what do you call it, artificial general intelligence by releasing GPT-5, it was a very big flop. So it's because, not because they had more data than before, but there is a limit to every technology that you can improve it. After that, you have to do some breakthrough. That's where the hierarchical reasoning model that actually come out from that has recently come out from a Singaporean university, hierarchical reasoning models. So again, I refer to the importance that we need to take on the two phases of machine learning: the training phase, where we have to get the right data, we have to properly pre-process it, especially when you have a multimodal modeling. We use if you use multiple models, like you combine text data with tabular data and image. So your model should take all these three things. For example, MRI scans, and also blood test results, which is a tabular data, MRI scan, which is an image data, maybe the suggestion from doctor, which can be a textual natural language processing task. So you are developing, you have I mean we have the capability to develop multimodal models so that you can combine. But when you combine it, developing the model, I mean, it's a very big topic. We can't deliver it in just 1.5 hours, but I just giving you hint. Multimodal modeling, uh, you have the right combination of data, how you combine, how you fuse the data, how you internally restructure. We call it sometimes in image processing, we call it latent space. How the probability distribution space, how are you going to align the probability distribution space of all these three models, all these three data types, so that you have the model or the neural networks or the transformer neural network or any other neural network will learn the features well from that specific data. So again, I mentioned, even after you develop the model, there is a challenging thing to maintain the model. So the two phases generally with is a very simplified. They tried with ChatGPT or even the GPT models, GPT-4 or GPT-5, trading with almost everything in the internet. So they have, actually there is a multi-stage trading step. It's not single stage. You have, just like humans learn in our schools, people give us language understanding first, especially for example English. They teach us English grammar, even though we are going to work as a doctor, or we have planned is to work as a doctor, because language understanding is crucial. So the same way, when we train a large language model, we provide language understanding. Then we fine tune based on a narrow data set. For example, if you're developing a conversational system, you will fine tune that model already got uh, a language understanding with a specific data set. For example, conversational. So if you are going with medical data, understanding medical documentation, the fine tuning stage will have a lot of medical documents as training sources. So in the same stage, actually, we have, I mean, one of the improvement is a human in a loop reinforcement learning. That was an improvement of GPT 3.5 over GPT 3, which made it more human-like. So human in a loop reinforcement learning. That's actually the third step. The fourth step is actually the prompt-based learning. Whenever we prompt, uh, we accept it or we reject the result. So based on that, the model will retrain, fine tune the model. So the most challenging task in any deep learning project, especially one of the challenges, we are facing a lot of challenges now. Uh, if you see, let's say we are working on road monitoring roads for potholes, cracks, faded road markings, foreign objects on the road, not many things. about 100 plus items. You can, the first intuition that we have is there are a lot of open source models that's pre-developed. You can just get that model, implement it, run. You will get 0% accuracy. We have experience where we had model, we deployed, and we got 0% accuracy because the camera position was different, the camera height was different, the angle was different. So the view will be different. So we had to collect more data from that. So the idea is, even though we say deep learning is brain-like and it can extract the features uh, implicitly. That's the difference between deep learning and other machine learning algorithms. Other machine learning algorithms, just like the diabetes data set you have seen, we have to extract the features manually and we have to provide the features. But in deep learning, in neural networks, the feature extraction is done by the model itself. But that's a stage where a lot of people are making mistake by just assuming that neural networks can do anything. So there may be, earlier I mentioned about explainability of AI. That actually is a research topic, is a topic in academics, but in industry is a very big thing. Because whenever a model fails, we don't have any way to identify why the model is failing. Sometimes the model learned from noise. That is because we assume the model to extract the feature, and model thought that noise was a feature of that particular image, and they learned from that noise and they made a prediction based on that. So we have lot of experience, especially when we have overlapping use cases, or we have, let's say for example, we train for pothole, we train for crack. So what happens when a pothole is over an area where there is a crack? So how the model is going to identify it, whether it identifies a crack or whether it identifies a pothole or identifies a both. Originally it should identify both. But now the model is maybe seeing a new use case where it assumes that is a new, something new, and the model may not identify it or identify falsely. This is just an example. So feature extraction is not easy. If we assume it to, if we assume that neural network is doing, it will do, but it may not be doing in the way that we are doing. So especially in voice processing, etc. You may be familiar with MFCC algorithms like MFCC. Sometimes what we do is we don't let the network learn from everything. We will extract some features from the data. These are just an older technique, but there are new techniques as well, as just I mentioned, something that we worked on. So if we can extract the feature and train the model, that will be better. We will extract the feature together with a subject matter expert. So I may be a machine learning expert, but in order to understand voice, the components of voice, what are the algorithms that work on voice, etc., I may need an expert on that. So he will say, if you use this algorithm, you can extract this feature. That is particularly relevant, for example, speaker identification, one of those projects that we worked on. Speaker identification, you may think is very easy, but when you have a system that need to identify the speaker from anywhere in a room, that's a very challenging problem, because the model is seeing, every time you are in the different area, the model is seeing a slightly different data. So you have to select, is better if you can select a feature that's prominent wherever yet you are. If you can select a feature and train based on that feature, is better in even in deep learning. So here you can see in normal machine learning, you have to extract the feature manually. in deep learning, the model, the network will extract the feature. But it's better, as I mentioned earlier, if you can give a more clear picture or a clear data or clear feature to the network to learn rather than just letting the model to learn, extract the feature. So that's a very good practice. Sometimes we practice it in industry as well. You see, uh, I'm not going into details. So we worked on the COVID prediction system as many people did. So a lot of people in those days, in 2019, in those days, actually there were no multimodal models and not image understanding using language models. So what we did those days is we take a base model and we do transfer learning. Transfer learning also assume you have gotten from your previous classes, where you take a base model, is a base neural network. You modify some part of the neural network, freeze other parts, and train only the modified parts. So a lot of people took base models like VGG16, and there were a lot of researchers those days in telling which base model is best for COVID identification based on how they are viewing into the features. So as I mentioned, VGG, maybe one model, one base model may be very good in object detection, but uh, our aim when we modify a model is to give record accuracy when we do the after doing the transfer learning. So that also is very important. So selecting the right base model was a challenging task those days, and those people who has gotten the best base model or developed a base model uh, for similar purposes has gotten a better product. Okay, we need to spend some time in Q&A. The class is up to here is 9:38, so it should be around 7:15, right? So how is our Q&A? Are we doing the full time discussion, or is it there is an option for Q&A?
Yes, sir.
So are we specifying any time for the Q&A? Or
Maybe we can spend last 5 to 10 minutes for the question answer session.
okay, thank you. So I was telling about cyber security issues related related with AI models. Generally, there is there is a lot of cyber developments in the cyber security area, because there are a lot of developments in cyber threats due to AI. But for AI developers delivering AI products, the most important issue that we are facing is uh, like things like model poisoning, etc. For example, we develop a model, we deploy it to the client, and someone is able to uh, fine tune, for example, without our knowledge, and they are able to change the model parameters. They are able to change the model capabilities in order to make, for example, we develop a fraud detection system, for example, just for the example. So that model poisoning is a big issue uh, happening uh, happening now. So the hackers are able to poison the model, modify the model, and make the model work in a different way. That also happens when we develop AI systems using tools uh, using LLMs, using platforms like LangChain. Are you familiar with LangChain, LangGraph, and all? platforms where you can use LLM orchestration to develop products using different LLMs. So prompt injection is one of such issue. So we may be formatting a prompt and using LangChain or any similar library. We will be sending that model to we will be sending that prompt to an LLM. But people, hackers are able to modify that uh, that prompts, and they are able to they uh, they are able to make the model work in a different way. So these are some. There are a lot of issues. I mean, the time is not enough to go into all those issues. That's why I mentioned if the participants can have more, if can interact more, if you can open up your mic, talk about your research or your experience with AI, your questions, I can delve more into my experience. That will be more worthy than going through slides, because if explaining each topic will take a long time. May I start the Q&A now? It's already 7:15.
Dear participants, the platform is open for question and answer session. Please raise your queries. Sir, there is a question in the chat box. Could you please explain feature extraction once again?
Okay, and I am not going to stop the presentation, and just I will go back to the slides. So let me go to, okay, you can hear me, right?
Yes, sir.
So what's a feature in the data? When we use data for machine learning problem, the algorithm, the model is learning from the data. When we mean learning from the data, is a very vague term. So it should be learning from some patterns actually. So in order to give that patterns, we have the data, and those data, uh, the components are called the features. For example, this is a data set for diabetes prediction. You may be familiar with this. This data set is called PIMA, Indian Diabetes Data Set, from Red Indian community. This data set is normally used to teach ML classification problems using supervised learning. So you can see that there are different columns that you can see. So this is an original data from women. So you can see the columns are pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes, pedigree function, age, and so and so. And the data says, one of the columns says they were diabetic or they were not diabetic. If it was 1, they were diabetic. It was 0, they were not diabetic. It was a real case. And those columns, and what we are going to predict in machine learning, we call it a target. So here the target is whether they are diabetic or not. That means we are using this data to develop an AI model that will predict whether someone will be diabetic or not the same person, some other person. If we input all those details, some other women, if we input their pregnancies, glucose level, blood pressure, skin thickness, insulin, so and so, the system will say they will be diabetic in the future. So that's the general workflow in machine learning. And those parameters, that the target is called a dependent variable in machine learning. All the other columns here are called independent variables, because these are the independent parameters collected from the human. So this is from where the model, the algorithm is learning the connection between all these features and the outcome. So that's why they are called a feature. So here is, we have extracted, generally we say we have extracted the feature because we know the parameters. But let's say if you ask, if If I ask you to identify between a tiger and a leopard, you may be able to tell this is a tiger, this is a leopard. But no one has ever told all the features that differentiate between a tiger and a leopard. No, people uh, just uh, just taught you this is a tiger, this is a leopard, so and so. So your brain already picked up those patterns that differentiate between a tiger and a leopard. So here, uh, in complex machine learning problems, feature extraction is almost impossible, especially when we work with image-based problems. So features are those parameters from where an algorithm is learning to make the prediction, whether it's generative AI or discriminative AI. So in tabular data, numerical data, etc., the features are already extracted and clear. But in complex data forms like images, video, etc., extracting the feature is difficult. And we may not, in some cases, it's impossible. So we let the network extract the feature. So again, the features are those parameters from where the algorithm is learning to make the prediction. Any other questions?
Sir, there are some queries in the chat box.
Hello.
Yeah, it's better if you can read because physics. Okay. Okay, hierarchical reasoning models actually is a very recent topic. Even I'm also exploring it. It's very recent, means just 1 month. So the idea is hierarchical reasoning models are not general purpose models like uh, uh, large language models. If in that sense, it can compete with LLMs. Actually, what they do is they do some hierarchical, basically they combine some uh, some capabilities of discriminative AI and Gen AI in order to work on a specific problem. So for example, you have a specific problem on deciding from a person input whether he got a heart disease or not. That's a very specific problem. So hierarchical reasoning models only work, at least for now, because it's very recent. It works only on that specific models. From the details of that, since we are not, as I mentioned, I'm not a full-time researcher. Actually, we work on those things that we can deliver. So we are still, our people are also still exploring hierarchical reasoning models. So accuracy is not always a metric for an ML model. Could you please tell which other metrics will be valuable for a medical disease diagnosis model? Accuracy is one of those metrics. But accuracy can be many things. For example, in medical diagnosis, sensitivities, other metrics like specificity. Uh, there are other parameters like F1 score, recall, in classification models, especially if you have an object detection. Now we have a recent, not very new, it's called MAP accuracy, mean average precision. So there are many metrics actually in order to find whether a model is good or not. But what I was telling previously is that even though the model is performing, in order for you to deploy it in your client application, you may have other factors as well. For example, just you are developing a medical analysis. You want to put it into a CT scan machine, but the model is very accurate. In all metrics, it succeeds. But it's not possible to put that model because of its heavy size. I mean, you mean it's a heavy model. It's not lightweight. You can put it in a device, or you can put it in, just assuming the case, you can't put it in a CT scan machine. Then that model is useless. So that's what I was telling previously. But in order to select a model for accuracy, there are a lot of metrics. It's not, I mean, actually, I am compiling, a lot of people mistake in this way. So I am compiling actually a book on that only how to evaluate a model, what are the metrics for different use cases. Actually, I have started compiling a lecture note on how to evaluate a model for different scenarios. Even as I mentioned, we are working on medical projects. In some of the cases, we have gotten 99% accuracy, and that's okay to publish as a paper. But we have not yet put that into production. Industry has not yet accepted it because they have other things for them to accept it. So that's all, maybe for a short discussion. How do we check if augmentation introduces artifacts that confuse feature extraction? That's a very real use case. We do augmentation for our benefit, but that will that may include noises. We have a very real example in our early road monitoring models, where we augmented the data in order to include nighttime performance. We just added augmented to have a nighttime vision, but it got a lot of we never looked into what was happening, but later we found that a lot of reduction in daytime monitoring accuracy was found after we do the augmentation. So you are very correct. But recently we are using some maybe I think this is not a proper time to explain it all. There are, maybe you can explain. Recently there are some ways to understand the explainability of the model. So the model it will tell on which layers or which parameters are influencing the result, so that even if it's a right result or wrong result, which layer, if it's a convolutional neural network, or which parameters. There are some, that's not a very complete area, but it's there are still you can search for model explainability in convolutional neural networks. Which are the features in audio input? Which are the feature extraction method other than MFCC? I'm not an expert in that. Actually, I work with the computer engineering and robotics department of here, the second largest University Putra, Malaysia. Actually, for us, they are doing they were doing, actually, we did a lot of projects previously. Even during the COVID period, we had an effort to identify COVID patients through app by just making them speak by using so the what we call the speech processing part will be handled by that university. I'm actually sorry for that. I'm not an expert in audio processing.
Since there are no further questions, we will conclude the session here.
Okay, thank you very much, dear friends. Maybe if any question you can, you can share any questions from participants. You can share with me later as well. I can answer as well.
Thank you, sir, for the highly informative session on machine learning foundations. Before we conclude this session, I request all participants to kindly switch on your cameras for a quick group photograph. On behalf of the organizing team, I sincerely thank our distinguished resource person for sharing valuable insights and making this session highly engaging. Thank you, sir. Thank you all for your participation. We have also shared the feedback link in chat. Kindly make sure to fill it out. We will be moving to the next session shortly. Kindly stay connected.
Thank you very much thank you very much, organizers and the participants. Let's meet again. Thank you. Thank you.
Thank you, sir.